Okay, I want you to imagine something. Picture a river, but it's wider than the Amazon and it's flowing silently right over your head. You can't see it, of course, but this thing carries enough water to either completely bust a decade-long drought or, on the flip side, unleash a totally devastating flood. So today, on The Explainer, we are going to decode these invisible giants in the sky, atmospheric rivers. I know, it sounds like something straight out of science fiction, doesn't it? But it's a very real paradox for water managers all over the world. I mean, how can the exact same thing be both a savior and a total destroyer? That's really the critical question we're going to dig into today. Can we actually learn to tame these rivers in the sky? All right, first things first, let's get on the same page. An atmospheric river, or AR as you'll hear it called, is not your average storm. Not even close. It's way more like a giant concentrated fire hose of water vapor. Think of it as this long, narrow channel stretching for thousands of miles, just pumping unbelievable amounts of moisture all the way from the tropics straight towards the poles. And just to give you an idea of the sheer scale we're talking about here, get this. A single strong atmospheric river can carry more than 25 times the amount of water that's flowing through the entire Amazon River. I mean, just let that sink in for a second. 25 Amazons. All that water moving silently right over our heads. It's a mind-boggling amount of water. And that right there, that's the core challenge. It's like two sides of the same coin. You see, when an atmospheric river makes landfall, it can be this incredible blessing, right? It can break long droughts with all this vital rain and snowpack. But if that same river is just too strong, or if it stalls out over one area for too long, it turns into a total curse, unleashing absolutely catastrophic floods. So that leads to the big question, right? How in the world do you predict something this massive, this impactful? How do we know if we're about to get the blessing or the curse? Well, the science behind forecasting this stuff has come a very long way. And wow, what a journey it's been. You know, back in the 90s, forecasters they were basically making educated guesses. They had really limited data. Then the 2000s roll around and we enter the satellite era. And that was a total revolution. For the first time, we could actually see these rivers of vapor. And now, here in the 2020s, we're in the age of AI and supercomputers, and we're achieving a level of precision that people just a couple decades ago could only dream of. But here's the thing. To make all this new precision actually useful for you, me, and for officials, scientists realized they needed a better way to talk about the threat. Just saying, hey, a big storm is coming, just doesn't cut it. So they came up with something called the AR scale, the Atmospheric River Scale, and it works a lot like the scale we're all familiar with for hurricanes. It's pretty straightforward. The scale ranks these things from 1 to 5. So an AR1 or a 2, that's going to be mostly beneficial rain. Good stuff. An AR3, that's kind of the tipping point, a balance of both good and bad. But once you get to an AR4 or an AR5, well, that's a major threat. That's when the risk of really dangerous flooding gets extremely high. Okay, so let's get to the cutting edge stuff. How is this new era of prediction even possible? Well, the secret ingredient, the real game changer here, is artificial intelligence. And it is completely transforming how we do this. And look, the real power of AI in all of this isn't just about speed. It's about perception. It's like a superpower. AI can sift through these enormous data sets and find these tiny, subtle patterns in the atmosphere that signal how an air is going to develop. We're talking about patterns that are literally invisible to the human eye. So you take that incredible pattern recognition, you combine it with the raw muscle of supercomputers, and the results are just amazing. I mean, we are talking about crunching billions of data points from satellites, from ground stations, in minutes, not days. And what does that mean for us? It means the forecasts are not only way faster, but they can pinpoint the timing and the location of the heaviest rain with a kind of precision that was just totally impossible even a decade ago. Which, of course, brings us to the next logical step. I mean, having a great forecast is one thing, but so what? What do we actually do with that information? How does it actually help us manage our water and, our future? And this is where the rubber really meets the road. So if water managers get a forecast for, let's say, a weak AR, they know it's safe to keep the reservoir levels high. They can capture every single drop. But, and this is crucial, if they see a strong, hazardous AR is on the way, they can do the opposite. They can strategically release water before the storm hits to create more storage space and prevent the dams from overflowing. And at the same time, emergency services are getting those early warnings out to people. And really, that's the ultimate goal of all of this. It's all about using this incredible science to walk a very fine line. On one hand, you want to minimize the destructive risk of these massive storms. And on the other, you want to maximize our ability to capture and use the water they bring. It's really about turning a potential disaster into a manageable and absolutely vital resource. Because when you get right down to it, this isn't just about data points and fancy computer models, right? All of this amazing science, all this technology, it's all in service of one thing: protecting people, protecting communities, and securing our future. And these better predictions lead to 3 huge, life-altering outcomes. For one, they save lives. That's because we get earlier, more accurate warnings out to people. They also protect property and all our critical infrastructure. And finally, they allow for much smarter water management, which helps secure our most precious resource for the long haul. But, and this is so important, none of this happens in a vacuum. The technology is amazing, but it's still just a tool. Its real power is only unlocked when everyone works together perfectly in sync. It's like a team. You've got the scientists building the models, and they have to communicate clearly with the emergency services who issue the warnings. And they have to be in lockstep with the water managers who are making those critical split-second decisions about our reservoirs. And all of this leaves us with a final and pretty powerful question to think about. As our climate continues to change, it looks like these atmospheric rivers might become even more intense and maybe more frequent. So the question is, will we master these rivers in the sky, or will we be mastered by them? Our ability to forecast, to adapt, and to act is going to be more critical than ever before. You know, the future of our water security might just depend on how well we learn to manage these vast, hidden rivers flowing right above us.